Now you will learn about wrapper classes. A wrapper class is a class that basically wraps a primitive data type, and it's basically equivalent to a primitive data type with properties of an object. So for example, integer, which wraps int, and to make one we can do integer, say I1 equals new integer 5, we just put the int value into there. And you can clearly see that integer has the properties of an object. And in fact, it also contains the toString method, so when I print it, it prints 5 in this case, or its value in general. And wrapper classes are interchangeable with their corresponding primitive data type. So for example, I'm allowed to do integer I2 equals 5, for example. And I'm also allowed to do, for example, int I3 equals I1, even though I1 is of type integer and I3 is of type int. And let's just say we have these variables right here, like so. Now, what happens when I do equals equals on these things? Try to compare them. So if we try I1 equals I2, what will it print? Well, actually it'll print false because they're not the same object. And equals equals compares whether two things are the same objects. But these two are both integers, so therefore, since they're not the same object, one of them's constructed and one of them's just 5, the result is false. So then, what about this one? I2 equals I4. That would actually be true because if you recall, if you don't use the keyword new, there's no new object. Both of these are just directly pointing to 5. Now what about this? I1 equals I5. False, because, well, both of them are constructed. They're a new object, so they're not the exact same thing, which was what equals equals checks. Now, what if we do something like I1 equals I3? What would that output? Well, actually, that's true. And the reason is because I3 is an int, and integer is interchangeable with int, so Java automatically converts one of them to int. So, or in general, if one of them is an int in the equals equals comparison, then only the value is compared. So for example, I2 equals I3 is also true because their value is the same. Now what happens if we try the less than on here? So say I1 is less than new integer 6. Well, this would just work like you would expect. Basically, when we're doing equals equals, we have to check whether they're integers and whether they're the same object, or whether they're primitive data types, and that means we just compare their values. However, if we're using operators like less than or greater than or less than or equal to or greater than or equal to, then we just compare the values. So I1 is greater than or equal to I2, and that would be true. And notice that in this case, greater than or equal to is not the same as greater than or equal to, since equals equals isn't always comparing values. How do I check whether two things are equal in value then? Well, since integer is an object, or extends objects, it contains the equals method. And in integers version of equals method, it just compares the values. So I1 dot equals I2, that would be true, as shown below. I1 dot equals I3, and now notice that I3 is an int and equals should take an object. However, this thing still outputs true because Java automatically converts I3 to an integer because integer and int are interchangeable. So then, therefore, I3 becomes integer form and they're equal in value, so this thing returns true. What about the following? I3 dot equals I1. What would that print? Well, actually that would cause an error because it says int cannot be dereferenced. Basically, I3 does not have the properties of an object, so therefore it cannot use something like an equals method. That's not allowed because int doesn't have equals method. That's integers method or other objects. So that thing would be an error. If you wanted to do I3 dot equals I1, you could cast it to an integer, of course, like that, because primitive data types and their corresponding wrapper class can always be casted to each other. So for example, right here, integer of I3 dot equals I1 would work. So when we print that, it would be true, as shown below. Now, let's suppose we had a method, public static void, let's call it x, that accepts as a parameter an integer. Let's call that I in here. And now we just say print integer I, just for our reference. And now, what would happen here? If we did x on, say, I1, which is an integer with the value 5, then as expected, it would be integer 5. Because notice that when a string is added with anything, whether it be a primitive data type or an object, the result becomes a string. So the result's just integer and 5. So that's no big surprise. Now what happens if I do x of I3? Then what would happen? Well, we noted earlier that integer and int were interchangeable basically most of the time. And the only time they weren't was when we had the thing had to call a method. So ints can't call methods while integers can. Otherwise, they're pretty much interchangeable. So then therefore, as a parameter, they're also interchangeable and would still print integer 5 as shown below. Now, suppose that we were to make another x. Now, if we made it accept an integer parameter again, then of course we would get an error saying that it's a duplicate method because it's same name, same parameters. Now, what if I change this type to an int? Then it would compile. So now let's just for a reference make this int and then I. Like so. What would each of these print? Where remember that I1 is an integer of value 5 and I3 is an int of value 5. So then what would this print? Well, the first one would print integer 5 because I1 is of type integer, and the second one would print int 5 even though I is of type int. And now why is that? Well, because when we say they're interchangeable, we mean that Java converts the types if they're not suitable. So if this thing were instead an int, Java would convert it to an integer. However, in this case, Java wouldn't even get to the converting process because, for example, if we call x of I1, Java would have to find which one of these two is the better one. Well, Java always chooses the more specific one. So in this case, integer is more specific because I don't have to convert it to int. So then x of I1, where I1 is an integer, would go to this one. However, x of I3, well, which one's more specific here? Well, int, because it's more obvious that I3 is an int than it is that I3 can be converted to integer. So therefore, Java decides that the way to execute this method is to call this x method, so then it'll print int5, as shown below. Just like int, every primitive data type has a corresponding wrapper class. So for example, int wrapper class is integer, so integer wraps int. Capital double wraps lowercase double. And the capital long wraps lowercase long. Capital Boolean wraps lowercase Boolean. Character wraps char. And short with a capital wraps lowercase short. Capital byte wraps lowercase byte. And capital float wraps lowercase float. And the other wrapper classes function just like integer do. So basically double d equals 5.7 is allowed. Double d2 equals 5, however, is not allowed, because although we're allowed to do double, say d1 equals 5, it converts int to the double. If we do double d0 equals d1, that's also allowed because lowercase double and uppercase double are interchangeable. However, in Java, this is just a double conversion that Java doesn't allow. You could always do something like 5.0 to bypass that though. So if we had int u equals 7, double d3 equals u, that wouldn't work. I would need to cast it to a double. If we do integer, say I0 equals 5.7, that would obviously not work because, well, even normal int set to a double would not work because of loss of precision. In addition to wrapping the primitive data types, wrapper classes also contain a useful parse method that converts a string to the corresponding primitive data type. So like for example, int a equals integer.parseInt 567, and now a would be 567. As shown below. And remember that if we did like int a1 equals directly 567, that would not work. And if I tried to cast it, it doesn't work. None of that works. So if you want to convert a string to an integer, you need to use the integer.parseInt method. Similarly, double b equals double.parse double 5.7. And also, for example, long l equals long.parse long 1 2 3 4 5 6 7 8 9 0 9 8 7 6 5 4 3 2 1. For example. Another method that's used in wrapper classes is a method that converts the wrapper class object to the value, although this is not needed most of the time. So int u0 equals, for example, we defined an integer up here, I1, which has value 5. We could just do I1.int value, and that would work. Now, one way this could be used is that this would allow us to bypass casting. So, for example, if we do x of I1, but we secretly wanted this thing to print int instead of integer, then because normally this thing would print integer 5 because it goes to this method. However, if I cast it, it does that. However, some people think casting is not a good thing to do most of the time. So you can always just do I1.int value, which without casting allows you to go to this int method rather than the integer method, as shown below. Similarly, the double wrapper class also has a value method. So double, just call this d4 equals, say, d up here dot double value. And similarly, long L0 equals new long of that dot long value, and so on. Another method that all numerical wrapper classes have is the compareTo method. So if we have, for example, integer c1 equals 5, integer c2 equals 7, the way the compareTo method is used is just one of them dot compare to the other one. And the way the compareTo method works is if the first one, or the calling object, is less than the parameter, then return a negative value. If the calling object is greater than the parameter, then return a positive value, and otherwise return 0. So if the two objects are equal. So for example, c1.compareTo c2 would be negative in this case because c1 is the calling object, c2 is the parameter, and c1 is less than c2. So this thing would be -1. So here's some exercises. Int c3 equals 6, integer c4 equals new integer 4. So what would the following output? Let's do c1.compareTo c3. What would that be? Well, that would be -1 because 5 is less than 6. And c1 is the calling object, 5. What about the following? c1.compareTo c4. What would that be? Well, that would be 1. Or at least you should know that it's a positive value, as shown below. And what about c1.compareTo c1? What would that be? Well, that would just be 0 because they're equal. And in general, for integer at least, the compareTo method returns -1, 0, or 1. For strings, however, that's different. It may return like values other than those three. What about, say, c3.compareTo c4? What would that print? Well, actually, that would be an error because, again, remember, c3 is an int. Ints cannot call methods. What about this? c1.compareTo c1.int value. Now this would just be, well, 0, because although c1.int value is an int, it gets automatically converted back into an integer. What about this? Printing c1.int value .compareTo c1.int value. What would that print? Well, that wouldn't work because c1.int value is an int, and int cannot access the compareTo method. And double with a capital, so the wrapper class also has a compareTo method. So if we do system.out.println new double 4.6 dot compareTo new double 9.7, then it would print a negative number, or in the case of double, it's just going to, similar to integer, always print -1, 0, or 1. Finally, wrapper classes generally have some constants that are useful. The integer wrapper class has the constants max value and min value, which are the maximum and minimum possible value of integer, respectively. And as you can see, integer.max value right here, integer.min value right here. And this is useful for, say, finding the minimum element in an array, for example. We just set the min to be integer.max value, then loop through the array and just do if I is less than min, min equals I. Why is integer.max value a good value to choose? If we choose a smaller value, there's always a chance that the array is entirely composed of integer.max value, and then you get the wrong answer. So therefore, integer.max value is a good thing to choose. Now, why can't you just choose ARR of 0? Well, problems occur when, like, let's just say I want to create a method of that, and the array has length 0, and we don't know that yet. Then this would be bad if we just did ARR of 0, because if the array had length of 0, it would be a runtime error. So yeah, it's pretty standard for integer.max value and integer.min value to be used in computing the maximum or minimum possible value of something. And double also has some constants, like double dot positive infinity, double dot negative infinity, double dot max value, which is the largest finite value, and double dot min value, which is the smallest finite value, and double dot nan. Now, these things for doubles, again, positive infinity and negative infinity, can be used for minimum and maximum value of something, but they can also be used for something else, which is checking whether something is equal to that. So for example, double UU equals 1 divided by 0. How do I check if U is an actual value or if it's a value like infinity or negative infinity or something like that? Well, we could check if UU is equal to double dot positive infinity, then we would be able to deal with some problems that would arise otherwise.